Hello all, and we're going to continue talking about extreme values. So if you haven't watched the lesson from Tuesday, I really strongly encourage you to do these in order. We're going to keep going with Chapter 4, Section 1, talking about minima and maxima. And we're going to introduce an idea of critical points. So if you're stuck on anything about minima and maxima for the last lesson, please nominate problems you're stuck on in the form or send me something in the comments so I can help you figure out where you're stuck and how to fix it. So if you're feeling ready to go, let's get out our notes and we're going to get started. We're going to keep, as I said, talking about extreme values, and we're going to introduce an idea with critical points. Now, critical points is a point where f prime, where the derivative is equal to 0. And so this is where the tangent line is horizontal. Now, this is an important idea with maxima and minima because we can look at different types of critical points, but what is important that happens is that if we look at critical points can be a local maximum, a local minimum, or it might just be someplace where the graph is flat. And so it's helpful for us to know where the critical points are because that helps us figure out if there's a max, a min, or it might be neither. And that's all right. Some critical points are just parts where the graph is flat. But if you can find a critical point, that is often a place that you're going to find a maximum or a minimum where you're going to find one of those extreme values. So the first thing I want to do when we're asked to find maxima and minima of a function using calculus, if it's not a parabola, because then you can just use the vertex formula, find the critical points of this more complex function. The way we're going to start is we are going to find where the derivative equals 0. So the question is, okay, critical points, that's where f of x is equal to 0. So the first thing we want to do is find f of x. Looking at this function here, we are going to want to use the quotient rule. So what I'm going to do in this case is I am going to say, okay, f is x plus 1. So f prime is 1. G prime for the denominator is 2x plus 1. So following the quotient rule of f prime g, so 1 times x squared plus x plus 1 minus g prime f, so 2x plus 1 times x plus 1 all over g squared, x squared plus x plus 1 squared would be the full unsimplified derivative here. Now I'm just going to zoom out a little bit. Now to find the critical points, we are going to set the derivative equal to 0, and I'm going to do a little simplifying. The first thing I'm going to simplify is I'm going to multiply by the denominator. 0 times anything is 0, so I've just canceled out the denominator. And then I will simplify the multiplication in the numerator and end up with x squared plus x plus 1 minus 2x squared, and the subtraction will carry all the way through, minus 2x minus x minus 1 when we FOIL, which leaves us with simplified negative x squared minus 2x. Since we're solving a quadratic for 0, I'm going to factor out, in this case, negative x, which leaves me x plus 2. So my critical points are at x equals 0 and negative 2. So these are where we have our critical points. And if we're thinking about what this graph is, so we have two of these. We don't know right now if they're a maximum, a minimum, or neither. As you can see here, that will be our second goal. So in order to find out where the maxima and minima of this function are, we're going to go through a little process. What I recommend is pause the video here, write down these steps if you would like to. So you're going to find the critical points. You're then going to make a number line, and you're going to test surrounding values, and you'll come to a conclusion. So I'm going to walk through this process, but I'll show you exactly what's happening here is that we're going to start finding the critical points, which we already did. Then on a number line, we are going to say, okay, here's our x values. The ones we're interested in this case are the critical points. So -2 and 0 in the case of this equation. Now, when I say test surrounding values, what that just means is pick numbers in each of these intervals that you haven't used yet, that you don't know about. And so in this case, I'm going to say -3, -1, and 1. What you're going to test now is the question. The thing you're going to test is to find the f prime values. Now, we know that f prime of -2 is 0, and at 0, that's the definition of a critical point. And what that's going to tell us, if we look at this picture I've drawn on the left, is that here f is 0, and it's positive, meaning it's increasing. The slope is going up as we go left to right. So it's positive, and then it goes to negative. If this happens, if we go positive, 0, and then a negative, that's a maximum of the function. Similarly, for a minimum, if we have a negative, a 0, and then a positive, that's a minimum of the function. If it's neither, that just means it's going to be the same sign. So in this case, it's positive, and then it's positive again. It could also be true if it's negative or negative. So if it's the same sign, it doesn't actually change. So it doesn't create a minimum or a maximum. So when we test surrounding values, just this question becomes, okay, well, what's f prime of 3? What's f prime of -1? And what's f prime of 1? And you could have picked any numbers here. I picked these ones because they're small and close. Like this could have been -17. That's also in that interval here. You could have picked -2.5. Whichever ones you like are fine. I think that these are kind of the obvious ones for this problem. But you can pick whichever ones you like. So you'll go back to the derivative here, and you can plug in your points. I am going to use my calculator since this is going to be a complicated set of problems. So I get that f prime of -3 is -0.612. F prime of -1 is 1, and f prime of +1 is -0.3, repeating, -1/3. So I'm just testing those around there. So this means that it's a negative at -3 in this interval, positive here, so we're basing it on the signs right down here, and then it goes back to a negative. So in this case, we're going negative slope, we have a 0, and then we have positive. So that means that we have a minimum at -2. Similarly, we have positive, 0, and then a negative. So we have a maximum at 0. So in my conclusion, I will say that we have a minimum value at -2, and we have a maximum value at x equals 0. If you want to find the points, you can plug it back into the f of x function, however you would like to do that. Now, these are both local extrema. This is a local minimum and a local maximum. You may also be asked to find the absolute minimum and maximum. And we are going to start this the same way, but we'll stop. We won't do every single step. So again, the first thing that you are going to want to do is you're going to want to find your critical points. So in this case, what that means is find f prime, which this is just a nice polynomial, so 3x squared minus 6x plus 0. Set it equal to 0 to find the critical points, so 0 is equal to 3x squared minus 6x. Again, this is a quadratic set equal to 0, so I will factor 3x and x minus 2. Therefore, saying our critical points are at 0 and positive 2 this time. Now, since we're trying to find our minima, absolute minima and maxima, we don't need to worry about the local. So we're going to skip right to the testing stage. And all you want to do is test critical points and endpoints. And what you're going to do is with the original function, because you're just looking for the biggest and smallest numbers of f, not f prime. So in this case, we were testing with f prime values. Here we're going to test with just regular f of x, the difference between minima and maxima. So in here, the values that we're going to test are f of x, and we have our endpoint, which is -1, 0, 2, and then our other endpoint 4, given this interval here. I'm just going to scoot that down real fast, give us a little bit more space. So we're just going to plug in these values into f and figure out what they are. So f of -1, f of 0, f of 2, and f of 4. So -1, I'm just going to use my calculator, is -3. F of 0 is 1, -3, and 17. So again, we're looking for absolute maximum here because 17 is the biggest of these 4 numbers, right? So the absolute max is at 4, and it's 17 as the ordered pair. And the absolute minimum is in 2 places because -3 are both the smallest. So at -1, -3, and +2, -3, and the absolute minimum value of the function is -3 there. So there you go, our different tests for our local versus absolute min and max using our derivative rules. Let me know if you have any questions, and I will get back to you as soon as I can.